Dear attendees, let me present you a report on the topic Application of Cloud Computing in the Process of Professional Training of Physics Teachers. Education is deeply influenced by the progressive introduction of information and communication technologies, which leads to the development and creation of e-learning or intelligent learning in environments on a global scale for educational technologies. E-learning uses state-of-the-art multimedia internet technologies, cloud computing, virtual and augmented reality to enhance learning experiences or learning quality, providing students with easy access to resources and services on the one hand, and facilitating remote exchange and collaboration on the other. Being popular all over the world, virtual laboratories are part of various fields of education. Virtual labs not only help students overcome the problem of lack of practical skills, but also help to overcome digital alienation and gain digital skills and abilities. It is clear that a virtual laboratory cannot completely replace experimental work and teacher work, but they provide practical support for the teaching activities of modern teachers and student learning activities. The COVID-19 pandemic has accelerated the digitalization of university education and the development of e-learning. The education system is undergoing a paradigm shift, which creates new opportunities in the learning environment, encourages the creation of new educational projects based on information and communication technologies. The acquisition of ICT competence by teachers and students is an urgent need for many universities due to the many benefits they can bring to teaching, learning, and research. Over the last few years, ICT has entered all levels of education, changing the roles of teachers, lecturers, and students. Information and communication technologies make it possible to create an effective creative learning environment in the learning process, which can lead to significant changes in the roles of both students and teachers, promote individualized learning, and improve students' motivation. The specifics of the training of future physics teachers is the free possession of physical instruments, a staging a physical education experiment, the use of modern digital laboratories. The equipment needed for this in a modern Ukrainian school is a rare phenomenon. However, to design the learning process based on the existing educational environment is one of the tasks of a physics teacher. Physical experimentation in physics is a must, so the teacher tries to use all possible means to organize it. Various options for improving the current situation should be considered, including the involvement of mobile devices for learning, the use of cloud computing to organize virtual laboratory work, computational experiments, joint research and publishing activities, and so on. The implementation of a mixed form of education with components of non-formal education in the program's secondary education physics can be very useful. E-learning allows future teachers of physics to update their knowledge, get acquainted with new devices and methods of experiments, update their knowledge of the use of ICT in educational activities. The use of virtual laboratories has many advantages. It allows you to conduct experiments at any time, feel safe when conducting dangerous experiments, see all the details of the experimental process, and take an active part in conducting experiments. On the basis of virtual laboratories, students have the opportunity to conduct repeated experiments until they are completely satisfied with the results of the experiment. Open education, among others, provides an opportunity to involve simulations and virtual laboratories in educational activities. For the educational program Secondary Education, Physics PhET simulations developed by the University of Colorado are well known. Harvard University has combined a variety of world-class e-learning resources on the Lab Exchange platform. As of November 2021, Lab Exchange contains 3,674 links to e-learning resources and their physics-related kits. Videos, simulation texts cover all sections of modern physics, contain information on the history of physics and the latest physical theories. In addition to simulations from the University of Colorado, there are simulations from the Concord Consortium. The simulations located on the GitHub resource are constantly evolving, but unfortunately these electronic educational resources are not cataloged. No less interesting, but unfortunately not free to use, is the resource PraxiLabs. The resource contains electronic educational resources in the form of virtual 3D simulations of laboratory experiments. The format of educational resources allows them to be integrated into popular learning management systems using LTI technology. You can get acquainted with the possibilities of the PraxiLab resource through demonstration simulations. Also quite interesting is the Lobster Virtual Lab. Once a week, the company holds a 30-minute webinar, which can be attended by no more than 100 people. It is at this webinar that the company introduces the conditions of use and opportunities for their development. Useful for the use in e-learning is a set of open e-learning resources from California State University, Long Beach, called Merlot. More than 6.8 thousand electronic educational resources are contained in the Merlot collection related to physics. The Epson Physics Simulator collection is developed and maintained by the Voltef and is constantly updated. As of February 2022, the collection contains 55 simulations implemented in HTML and implemented in 19 languages, as the Ukrainian language is not available. The simulation covers all sections of the school physics course and can be run on different devices. Consider in more detail the example of the use of virtual laboratory workshops. The software to support the study of the discipline molecular physics includes simulators of physical processes, tools for processing and visualization of measurement data, tools for creating electronic educational resources, and more. Studying thermodynamic isoprocesses in gases, you can use the established laboratory installation. In this case, to calculate the results, it is necessary to use software for processing tabular information. Physical simulators have animation and detailing of processes that the researcher during the physical experiment cannot observe the available methods. Physical simulation of PHET properties of gases also has such properties. The proposed scheme of using physical simulations is suitable for both independent work and group work, without excluding the distance learning option. The example of a task using computer simulation is as follows. Using computer simulation of physical processes, PHET gas properties at a constant volume to determine the relationship between gas temperature and pressure for different gases and their proportions, light, heavy, different number of gas molecules. Record the results of research in this table. The results of measurements are presented in the form of a graph of pressure versus temperature for different numbers of molecules of different types. An example of such a table is the table in Figure 5 made in the Google Spreadsheets cloud application. Thus, the use of virtual training laboratories for the study of natural sciences significantly increases the efficiency of the educational process, makes it more meaningful, in-depth, promotes digital skills in students and teachers, improves learning and simplifies distance learning and/or blended learning. It became very popular during the COVID-19 pandemic. Indeed, a virtual simulator cannot completely replace physical experimentation and teacher explanations, but virtual laboratories can support the teaching activities of a modern mentor, student learning activities, increase professionalism, open new horizons, and most importantly, strengthen the motivation component of learning through active student dialogue. By guiding him on a path to success and mastering basic knowledge of natural sciences, including physics. Thank you for attention.